Hello everyone. Today we will try to calculate the degree of freedom of a dynamical system. What is degree of freedom of a dynamical system? The degree of freedom of a dynamical system is defined as the minimum number of coordinates required to specify the position of a dynamical system. The system may consist one or more particles. Now we will try to understand that how we can calculate degree of freedom of a dynamical system. Let us take the first example. Suppose there is a long wire and an object is placed on the long wire. Here you can understand that this object can move along the length of the wire, or so it will have here in this case the degree of freedom will be 1. Now let us take the second example. Let us take an object in two-dimensional space. This is the origin, and this is your x-axis, and this is your y-axis, and object is placed here. You know that to specify the position of this object in two-dimensional space, you require here two Cartesian coordinates x and y. First we move x and then we move y. So here the degree of freedom in this case will be 2. Now let us take the third example. Suppose an object is placed in a three-dimensional space. This is your x-axis, this is your y-axis, and this is your z-axis, and it is origin. And the object is placed here. Okay, to specify the position of this object, you very well know that you will require three Cartesian coordinates x, y, z. So here the degree of freedom will be 3. Now I am taking the other example, that is number 4. Let us say there is a three-dimensional space. This is the origin, this is x-axis, this is y-axis, and this is z-axis. Let us say there are two objects placed in this three-dimensional space. This is object number 1 and this is object number 2. Object number 1 will have the Cartesian coordinates, let us say x1, y1, z1, and the object 2 will have the Cartesian coordinates x2, y2, and z2. So here for this dynamical system, the degree of freedom will be 6, because here the 6 Cartesian coordinates are required to specify the position of this system, or you can write it as 3 into 2. Here 3 is representing the space, and 2 is the number of the particles, right? Now I am taking the other example, that is number 5. Here it is to be noted that in this case, example number 4, the distance between the objects is not constant, or it is varying at any instant. If object number 1 has the Cartesian coordinate x1 y1 z1, and the object 2 has the Cartesian coordinates x2 y2 z2, then here the degree of freedom will be 6. But if I take the case that let us say this is the origin, and this is your x-axis, this is your y-axis, this is your z-axis. Now I am saying that this is the object 1 and this is the object 2. It has the again Cartesian coordinates x1 y1 z1 at an instant. This is having Cartesian coordinate x2 y2 z2 at an instant. Here what is I am taking that the distance between the two objects is constant. This is a very important to understand, that the distance between the two objects is here constant. So what will be here degree of freedom? Here degree of freedom will not be 6. Okay, here degree of freedom is equal to 5. First I will write the formula of the degree of freedom. You have to remember that the degree of freedom of a dynamical system can be written as it is for 3-dimensional space we will write here 3 and multiplied by the number of particles minus restrictions. So here what will be the degree of freedom, as we have already written here in this case it will be 5. So because it is a 3-dimensional space, the number of particles is 2, so it is 2 minus 1. So here restriction is 1. What is restriction? That the distance between the two objects is constant. So here degree of freedom will be 5. Now I am taking the other example. Suppose there are 3 particles in 3-dimensional space. This is your x-axis, this is your y-axis, this is your z-axis, and this is the origin. This is particle number 1, this is particle number 2, and this is particle number 3. Say particle number 1 has the coordinate x1 y1 z1 at an instant. Particle 2 has the coordinate x2 y2 z2 at an instant, and particle 3 has the coordinate x3 y3 z3 at an instant. Here the restriction is that the distance between the object is constant. Let us assume the distance between object 1 and 2 is constant, the distance between 2 and 3 is constant, and the distance between object 1 and 3 is constant. So here in this case the degree of freedom will be 3 into 3 minus what are the number of restrictions? The number of restrictions here 3, because the distance between particle 1 and 2 is constant, the distance between particle 2 and 3 is constant, and distance between particle 1 and 3 is also constant. So here the degree of freedom will be 6. Now I am taking the other example here also. If here we have considered the 2-dimensional space, here we have considered three-dimensional space, but if I consider a two-dimensional space, then your formula for the degree of freedom, you have to remember this. It will be that it will be 2 into number of particles minus restrictions. Okay, so suppose there are two particles in a two-dimensional space, and the distance between the particles is say constant, then the degree of freedom in this case will be 2 into 2 minus 1, it will be 3. Thank you.